And good morning. Happy Friday. It is that time to do some geometry. Make sure you guys have turned in your work on Google Classroom. I will be updating Skyward today right after class. So if you haven't done that, make sure you do that quickly. Okay? So what we're going to be doing today is we're going to be reviewing 5.1, 5.2, and 5.4. You will have a homework assignment tonight from 5.2. Okay? So let's go ahead. We have a lot of notes to take, so we're just going to go ahead and dive right into it. Okay. So the first thing we're going to start out with is 5.1. Now remember, I'm not going to be teaching all of this stuff. I'm just reviewing it. So if you have questions, make sure you guys use the chat or turn on your mic and ask a question. So the key part from 5.1 was the triangle sum theorem. So we're going to recap that, but then we also need to look at something that maybe your geometry teacher didn't cover about it. I know that we didn't cover it in my class. Okay, so this is the triangle sum theorem. Okay, so I'm going to do this kind of as a visual because, again, I'm not teaching this for the first time. This is review, so if you guys have more questions, let me know. But the triangle sum theorem basically said if you have a triangle, and it's any triangle, and you have three angles, okay, and you have three angles, then what we know is that those three angles are going to add up to 180 degrees. Okay, so that was the triangle sum theorem, right? So it doesn't matter what triangle it is, they will always add up to 180. Now what's really important here, right, that was the basic, but there's a really good chance that you guys didn't do the second part, and I know I didn't do the second part with my students, and that is if I have two triangles, and so you guys are going to definitely want to get this down. So let's say I have two triangles, and let's say in these two triangles, two of the angles are 40 degrees and 60 degrees, and then in the other triangle I'm going to have 40 degrees and 60 degrees. Okay, so get that down. So again, this bottom part here is going to be new. You guys haven't seen this yet. Okay, so the triangle sum theorem is real basic. You guys did that in middle school, right? But this is going to be something that's a little bit new that we're going to be using a lot this trimester. Everything we're taking notes on, we're going to be using a lot this trimester. Okay, so the idea is if we just look at one of these, right, we can use the triangle sum theorem. That is, if this is 40 degrees and this is 60 degrees, and this angle up here is some angle theta, right? We can figure out on our own that this angle, it has to be 80 degrees by the triangle sum theorem. Okay, because 40 plus 60 equals 100, and so that has to be 80 because it's 180 degrees. Okay. So now if I were to look over here at, say, angle phi, okay, this one would also have to be 80 degrees. And that's also because it's a triangle sum theorem. Okay. So both of those have to be 80, right? And that's just using the thing that we've already been doing. So this new property that this is that we can say then that angle theta is going to be congruent to angle phi, and we can say that because the book calls this the third angle theorem. Okay, the third angle theorem, and I'll write that down in just a second. But basically, the third angle theorem is just saying if you know two corresponding congruent angles, then the third angle has to be corresponding and congruent as well. And we're going to write that down right now. And you're going to want this in your notes because this is brand spanking new, right? So if you have two corresponding congruent angles, comma. So if you have two corresponding congruent angles, should say pair, shouldn't I? I'm going to add in pair there, right? So if you have two pair of corresponding congruent angles, then the third pair must, so then the third pair must be corresponding and congruent. Okay, and I use some symbols there to speed up the note-taking process, okay? And again, if you guys have questions or comments, or if I'm going too fast, you can use chat or you can turn on your mic and do it that way, okay? So if you have two pair of corresponding congruent angles, then the third pair must also be corresponding and congruent. So you guys are going to need this. We're going to be using this as the year rolls on, okay? So using triangle sum theorem, right? The idea that the angles in a triangle add up to 180, but also if you note, if you have two pair of congruent corresponding angles, the third pair also has to be congruent, okay? Are you guys doing okay? I haven't had a single person use chat yet today, or use their mic. Are you guys there? Can you hear me? Like, is my audio working? Is the stream working? You guys, okay, there we go. All right, it's always nice to have a first, right? It's always good to say hello to your teachers too. I coach soccer, and I always tell my players that make sure you always say hi to your teachers once so they don't mark you absent, right? Not that I'm going to mark you absent if you don't say hi, but it's just a good practice, guys. Just a good skill there. You know, as a teacher, I'm supposed to teach you guys life skills as well. All right. Yeah. Good morning. Good morning. All right. So, again, I'm glad you guys are here. I'm glad, and happy Friday, guys. I'm glad that we're here. We're going to make it, guys. We're going to make this together. I believe in that. So 5.1, triangle sum theorem, right? That's review. This is new, though. You're going to want it. Everything that we're doing today, you want in your notes because we're going to be using it a lot. And you want it all in one location because we're going to be referencing it quite a bit. Okay, so that was 5.1. Okay, now I'm going to skip ahead a little bit. We're going to go straight to 5.4. We're going to end with 5.2 because your homework assignment is out of 5.2. So let's start with 5.4. And 5.4 was all about special triangles. And I am going kind of at a quicker pace today because we do have a lot to get into our notes, okay? So special triangles. There's two types of special triangles, okay? So two types of special triangles. The first one that we're going to take a look at is an isosceles. Okay, so I'm going to do this with pictures as much as I can. So for an isosceles triangle, we're just going to draw a big triangle so we can label it. It's defined as being, right, so we have two congruent sides. So two congruent sides. Okay, now to mark the sides, we use tick marks, right? Now I use 2 tick marks. You can go ahead and use 1 or 2 or 3, just as long as they're the same. And really, it can be any symbol. It's just that we're going to use tick marks to do that. Okay. This is called our legs. And the one that's not congruent, that's called our base. Okay. And on our base, we have a thing called base angles. Now remember, the base angles are going to be opposite of the congruent sides, right? And vice versa, right? So there's this relationship between congruency. If the angles are congruent, then the sides opposite are congruent, right? And vice versa. So this relationship goes both ways. And again, I'm not teaching right now, so I'm reviewing. So if I say something that's confusing or you need a little bit more clarity, please just let me know with a private comment and I can help you out. Okay, so let's write this down. So we also know that there are 2 congruent angles, and they are opposite of the congruent sides. Okay, and that's vice versa as well, right? So if we have congruent angles, then we know we have congruent sides. And if we have congruent sides, we know we have congruent angles. Okay. One last thing. So we have, so these, well, a couple more things. Sorry. So these are base angles, right? Because it's all about that base, right? So we want, that used to be a funny joke when that song was popular. So it's all about that base because we got a base side and we have base angles. Okay. Now everything else got a label, so we don't want to leave out the top. The top angle up here is called the vertex angle. It's called the vertex angle. So again, we're just going through everything here and just reviewing things that we've learned. Okay. Now, a couple of things. So this is kind of like all English stuff, right? So if I wanted to define an isosceles mathematically, I might go, okay, if this bottom left is A, if this top is B, and this is C, then how we're going to use this, so we're going to be proving triangles congruent. That's what we're going to be doing for the rest of this, for the next month. So in doing that, we want to know, okay, well, how are we going to use isosceles triangles to help prove triangles congruent? And we're going to be using that by saying the definition of isosceles triangles. Okay? And what this says, right, by the definition of isosceles, it would say that I'm going to have two congruent legs. So I would have segment AB is congruent to segment CB. Right? So by definition of isosceles, those two sides have to be congruent, right? Because they're not the base. Okay. So this is right. So we're just doing examples for everything. So how we would use it in a proof, right? So by definition of isosceles, those two are congruent. But we can also say angle A is going to be congruent to angle C by definition of isosceles as well, right? So this is a little example of how we're going to be using that, right? So if we see we have an isosceles, then we can say, hey, these parts are the same, which is going to be helpful if we're going to be proving triangles are congruent, and we're going to talk about that. That was 5.2, right? Congruency. Then we need to know all the parts are congruent, so we need to be able to have statements for that. All right, are we doing okay so far, guys? Is the pacing okay? Are we doing okay? Again, I'm kind of moving quick because we do have a lot of notes to take. Thank you for the thumbs up. I appreciate that. Yeah. All right. So let's move on then. So that was one special type of triangle. The other special type of triangle is an equilateral. Okay, so an equilateral triangle. Now, remember, if you're studying root words, it can really help you go out here. So equa, right? So if I cover up that part, equa means equal, so the same, right? So equa means the same, and then lateral means straight. So this if as a crude translation would mean same, straight. Okay, so we can interpret that to mean all the straight pieces are the same. Okay. So if I were to draw an equilateral triangle, so this one isn't as special. There's not like special names for anything. So we know that all the straight pieces are the same. Right now I'm making it look like a hyperdrive for Back to the Future. Now I can't even remember what it's called. Oh, that joke was ruined. All right, so what do we have here? All three sides are congruent. Okay. And then most importantly, remember with isosceles triangles, right, there's that relationship between congruent sides and congruent angles. So if all the sides are congruent, then all of the angles across from the congruent sides are the same as well. But it turns out, right, so this is combining, right? If all of these angles are congruent, right, so if all angles are congruent, but they have to add up to 180, right? So in my class, we did that together, right? To show like, hey, if you forget. But the only way that three angles can add up to 180 is if they're all 60, right? So because all of the angles are congruent, they all have to be 60 degrees. They all have to be 60. Or pi over 3 radians, but you guys don't have to worry about that. Neat. Okay, so equilateral, I mean, equally as special, but less to remember, right? There's a lot less to remember, which is nice. But also remember, the reason why we're taking such good notes today, guys, everything we do this trimester is open notes, right? Your homework is open notes, your exams are open notes. So it's really important we're getting good notes, because if you get stuck, you can always go back to your notes. Sweet. So that was 5.4. Like crazy, right? So we're going to spend the majority of our time looking at 5.2 and then reviewing everything we did first in geometry A, whether that was first trimester or second trimester for you. Okay? And we're just going to take really good notes, because there's going to be one proof on your homework. And in order to do proofs, we have to have all the rules. So we're going to make a one-stop location for all the rules. So that way you guys have it all in your notes and you're ready to go. Because I don't want you guys to be frustrated. I want you guys to kick some serious booty. All right. So let's take a look at 5.2. So your homework is going to be out of 5.2 tonight, because we're going to be talking about congruent triangles for the next month. So if we're going to talk about congruent triangles, then we need to refresh on what it means to have congruent shapes. Okay. So let's take a look at this. Now, I'm going to emphasize triangles a little bit in this one, okay? So, for example, for triangles, I just said fro. Oof. Thinking too fast. For triangles, let's see here. For triangles, in chat, tell me, how many parts are there to a triangle? So in chat, can you guys tell me how many? See, I'm getting all different answers. Yeah, I'm getting all different answers. So I think a lot of people, and the majority of people, are getting thrown off by try, right? So what if I broke this down, right? So how many angles are there? Can you guys tell me how many angles there are? Oh, there's 3 angles. Okay. How many sides are there? Oh, okay. So you guys were telling me that there's 3 parts, but there is 6 parts. There's 6 parts. Yeah. So there's 3 angles and there's 3 sides. So there's 6 parts total. Okay, so there's 6 parts total. So that's important. See, this is why we're reviewing this, guys. This is why we're doing this, right? And I appreciate the participation, because when you guys participate, then that lets me know we need to talk about it. So thank you. I really appreciate everyone who participated there. Okay, so there's 6 parts. So we're going to look at this a couple of different ways. So if I were to have a congruency statement, so if I had triangle TRY is congruent to triangle PLS, and I'm maybe trying to do subliminal messaging to you guys. Okay. So we got to remember, this is a congruent statement. Oops, sorry, I was off there. So this is called a congruent statement. Now, what's really important here is we want to be able to, given a congruent statement, we want to be able to identify all the congruent parts. And there's 6, right? There's 3 angles, 3 sides. So if I take a look at the angles, right? Always do angles first. They're the easiest. Now, some people have difficulties doing this. So if you need to help you out, you can always go like this, right? T is the first letter, R is the second letter, 3 is the Y. Y is the third letter. So I have 1, 2, 3 over here. So remember, in a congruent statement, order matters. And that's the key here. With congruent shapes, order matters. And you're going to keep hearing me say that for the next month. Order matters. And order is really important. So, for example, if I have, let's do this in red. If I have angle T, so angle T comes first. So then I automatically know that's going to have to go with angle P because T and P are the first letters. Okay, and then we can follow this pattern. The second letter is R, and that's going to go with the second letter. And then the third letter is Y, and that's going to go with the third letter. Okay? So remember, in congruency statements, in anything congruent, really, order matters because we're talking about things that are the same. So they have to correspond, right? They have to go together. If the pieces aren't corresponding, right? If you have all the same pieces but are in the wrong places, then they're not congruent, right? Imagine you have two calculators that have all the same buttons, but the buttons are in different places. Those aren't the same calculators, right? Okay, so super important with congruency statements, order matters. So the first with the first, second, and so on. Now, I know some people struggle a little bit with sides, but remember, if you have a congruency statement, you don't need a picture. Okay, and that's the beautifulness of congruency. The beautifulness? It's like crap. Figure out your grammar. Okay, so sides. So remember, to name sides, right, there's segments, so you're going to need 2 letters. So what if I just take the first 2 letters? So let's, I should use red. So let's say I use TR. Okay, so I have segment TR. Well, what's cool is order still matters. So T still goes with P, and R still goes with L. So side TR must go with side PL. Okay, so you're just using the fact that these have to be in order, and they have to be corresponding to figure out this without a picture. Okay, so I used the first 2, right? So let's use the last 2. So I can use RY, and if these last 2 go together, then it should go together with the last 2 here. Okay, and you can double check. R still goes with L, Y still goes with S. So we're preserving that that order. Preserved. Sounds like pickles. Okay, and then so we use the first 2. We use the last 2. The only combination we haven't used is the first and the last. So I can say, hey, what if I have TY? Well, then that's just going to be the first and the last of my other shape. So again, notice how T goes with P and Y goes with S. So if you flip these, you can totally flip these letters, right? Then you just flip these as well. How are we doing with this, guys? You guys doing okay? Does this, you guys are like, Kraft, we feel good. We did this. You guys are so excited. Like, you're at home and you're taking your Chromebook and you're like twirling it above your head and be like, this is so awesome. And like whoever else is in your house is trying to figure out what's going on. No, that's not what's happening. Oh. Well, I mean, you know, I was gonna make a joke about being able to see you, but technically with GoGuardian, I can do that. I don't use GoGuardian, by the way. I think it's an invasion of privacy. If you guys aren't being motivated to get work done, then that's something you need to figure out. Me telling you to be motivated won't fix that. All right, let's do an example of this. So I'm going to draw a shape, and you guys are going to want to draw this too. So I'm going to stray away from triangles just for a little bit. Okay, I didn't draw these very well. You're just going to have to let that go. Okay, I didn't draw these very well. We're going to label these. So on the left, we have D, E, F, G. When you label, you always go clockwise when you label. And then we have N, P, Q, M. Yes, I could have spelt something there and I didn't, so get over it. Okay, so if you guys could get those down, that'd be great. That'd be neato. That'd be just real nice. And then we're gonna add some things on this, and we're gonna do a little problem, okay? So I'm gonna start with the left. I'm gonna add some things here. At the top, I'm gonna put 8 feet. Right? Probably really stinky up there with so many feet. And then I'm gonna have 102 degrees, and then 84 degrees. Now this picture is not drawn to scale, right? We're just using it as a tool to help us understand the problem. So there's 68. So in this one I have 8 feet, I have 102 degrees, I have 84 degrees, and 68 degrees. And then over here for MQ, that's on the bottom, I'm gonna have x minus 2. I'm gonna put parentheses around that and put units on that so we know it's a side and not an angle. And then for angle P here, I'm going to go 3 plus 2y. So that's 3 plus 2y. And then I'm going to put a little degree above it. Okay. All right. Then, to add some information to this, we're going to say that the shape DEFG, I'm not putting a triangle in front of it because it's not a triangle, right? It has more than 3 sides. So shape DEFG is congruent to shape QMNP. Okay, so there's our congruency statement. So now we're going to solve for x and y. Okay. And again, if I'm going too fast, sometimes I get really excited and I just want to like boom, 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 boom because I'm so pumped up, you know? Like sometimes you just get really excited and you just want to go. So if I am going too fast, remember you can always just tell me in chat, hey, Kreft, you're going too fast. Looks like we're making good time, though. We are making good time. Just keeping my eye on the clock. That's why I always have the clock on our screen so that we can see where we are in class. All right. So, what do you guys want to solve for first, x or y? You can type it in chat. What do you guys want to do, x or y? Okay. I saw x first. Okay. So I'm gonna look for where x is. So the first thing I notice, it looks like I have x. Man, I got a lot of burps. Looks like we have x on a side, right? So the first thing I'm going to do is be like, okay, what side is this? This looks like side MQ. Okay, so MQ is right here. Okay, so it looks like side MQ is the first 2 letters. So then I automatically know that that's going to go with side ED. Okay, so if I look for side ED right here is 8 feet. So I'm going to just write this down because I'm going to show all my work. What I'm saying here is I know that segment MQ is congruent to segment ED, right? And I got that from my congruency statement. MQ is x minus 2, right? So MQ right up here is x minus 2. Now I switch to values, right? So I can go to equals, right? We use equal for value. We use congruent for shapes. So I can switch to equal here. And then ED is 8 feet. Okay, so now I can solve for x. Okay, so to solve this for x, right, I would add 2 to both sides. So I get x equals 10. Neat. Okay, so that's just an example of using a congruence statement, right, to help us identify key parts and solve. I bet you guys were all like, yeah, we got it. Oh, yeah, that's teamwork. It's always better when we're together, right? Thank you, Jack Johnson. Okay, so now let's solve for y. So if I'm going to look for y, right, it looks like there's a y in this one up here, and it's an angle, and that looks like angle P. So if I circle angle P, right, it's the last letter. So then the last letter over here is G. So I know that angle P is going to be congruent to angle G. G for G'd up, or G unit, or they are OG. Okay, so P, what's P? P is 3 plus 2y. And then I can change it to an equal sign because I'm talking about values now, right? Sounds like we're at church, right? So we're talking about values now, so I'm going to have equal. And then what's G? G is 84. Boom. Okay, so I have 3 plus 2y equals 84. Okay, so now once you get your equation, right, we're going to solve. Okay. Holy moly, I got 20 minutes. So we do have to speed up just a little bit. So if I subtract 3 from both sides, I get 2y equals 81. And if I divide by 2, I get y equals, I think it's 40.5. Yeah, that makes sense because 2 goes into 80 40 times. Okay. All right. Does anybody have any questions? So you're going to have a big part of your homework is going to be about doing that. Okay. So again, a big part of your homework will be doing this. That's why I did an example. All right. We have a lot of notes to do, and we have about 18 minutes to do it. So I'm going to start. I'm just waiting for people to get this down. As we're going through the notes, can I just say this? I might have to speed up if we're running out of time. Remember, this video will be posted to YouTube. If for some reason I'm going too fast and you don't get something down, leave space to take notes and then go back to the YouTube video later and copy it down. And I wish in a perfect world, right, that wouldn't be an issue, but we only have 15 minutes. So again, for this next part, I'm going to write down all the rules that we have so far in geometry, right, from first trimester. And if for some reason I have to speed up because I need to get them all in, just remember this whole lesson will be on YouTube. And you guys can fill out your notes then. Now, just as another disclaimer, the triangle sum and the third angle, we already wrote those down, so I'm not going to include them here. Does that make sense? So they're already earlier in the notes, so I'm not going to write them down twice. Okay, so I'm going to write down each geometry rule that we've learned and then give a quick little example. Okay, so the first one we have is complementary. That was punny. So complementary angles. Now, if you had me as, well, we'll talk about that in a little bit. There's an easy way to remember complementary angles that I teach my students. I don't know if your teacher told you. So complementary angles. So all that is two angles that add up to 90 degrees. And again, I have to go relatively fast. So if you find yourself falling behind, just get the big names down and come back later and fill everything else in. The one that goes with this is the supplementary one. Now I have a really funny way of remembering these, and it's a great story. But if we don't have time for a story, so just what I teach my students is think of P as 90. If P is 90, see how this one has two P's? That's 90 plus 90. So supplementary will always be bigger than complementary because it has more P's in it. So that's the easy way to remember, hey, which one is 180 and which one's 90. Okay, so supplementary has two P's in it. It's 180. So again, it's two angles that add up to 180 degrees. Okay, and I do want to give a quick little example of this and how this would be used in a proof. Okay, so how would this be used in a proof? Well, you'd have your two-column proof, and you most likely would have a given. You would probably be angle 1 and angle 2 are complementary. Sorry, I ran out of room. Sorry, that says angle 1 and angle 2 are complementary. I just had to go with the doctor handwriting because I was running out of room. So that will probably be given, right? So then what can you do with this? Well, if angle 1 and angle 2 are complementary, that means two angles that add up to 90. So I can write an equation. Okay, so I can say if they're complementary, that means this, right? And what I would write is I would write definition of complementary. Pro tip, if you guys want another pro life tip, if you're ever writing something and you like halfway through it, you forget how to spell it, just go into doctor handwriting and then they can't read it anyways. And so no one can call you out on not being able to spell it. Not that I don't know how to spell it, that's just a pro tip. Okay, and always guys, as we're going through this, remember this will be on YouTube later, but I'm here now. So if I do something and you have a question, please go ahead and ask. Okay, please go ahead and ask. Especially since I'll be answering it on the YouTube as well. On the YouTube. Oh my gosh, how old am I? All right. So there's our first two. You guys doing okay? All right, I'm just going to assume you guys are doing okay because no one's saying otherwise. You guys are very quiet today, especially for like 30, 33, 32 students. Here we go. We have a midpoint and bisector. I'm going to group these together. That's an E. I tried to get that to be an E. Okay, so midpoint and bisector. So they do basically the same thing, but I'm going to give an example of each. So midpoint and bisector. So what they do is they make two equal parts. Now, remember, the whole point we're doing this is we want to prove triangles congruent. That's what we're going to be doing this month. So being able to have two equal parts is really good, right? Because we need 6 parts, right? So this is really good. And it does this by cutting it in half. Okay, so we get 2 equal parts by cutting something in half. So I'm going to give 2 different examples of this. Okay, so example uno would be, I have a segment, let's call it AB because Mr. Kraft isn't very creative, and then I'm gonna have C. That, and I don't have a sense of humor either, so I mean, absolutely. So I've been saying this from the beginning. You really should be taking notes on all of this because you might have taken notes on this first trimester, but they're all over in your notebook. If you take notes on this now, it's all in one place. And we're going to be doing proofs where we need all of these. So if you, right, so having these all in one place, right, I wouldn't do this if I didn't think it was worth your time. I will never do something that I think is a waste of your time. If I think it's a waste of time, I just won't do it. All right, so if C is the midpoint of segment AB, so if C is the midpoint of segment AB, then segment AC would be congruent to segment BC. So again, I'm just doing an example of what this should look like. Okay, so if C is the midpoint, then we know that the left side and the right side might be congruent. And you might want to use like a little tick mark like this to say, hey, those two segments are congruent. Okay, so if C is the midpoint of AB, then AC is congruent to BC. Oh my gosh, I only have 10 minutes left. All right, I will have to speed up a little bit. Okay, and then let's say I have an angle with that is being bisected. So I'm going to go ahead and label this. This would be like A, B, C, and D. So how would I write this down? So I just have one big angle with a ray going down the middle. And I'm going to say if
BD, ray BD, bisects angle ABC.
Okay.
We should put an if. Then,
right? So if ray BD bisects angle ABC, is this kind of fuzzy? It's always fuzzy in that corner.
Okay. Then, right, then I know that angle ABD is congruent to angle CBD.
Okay. So again, notice how whether it's a midpoint or a bisector, I'm going to end up with two congruent parts. Okay. So whether it's a midpoint or a bisector, I'm going to end up with two congruent parts. All right, we got 10 minutes left, and we have a lot more to do.
So again, if you don't get everything down, this will be up on YouTube later to fill out your notes. And yes, you should have this in your notes because, like I said, we're going to spend the next month doing proofs, and you want this all in one location. Okay, now I'm going to put transitive and substitution together because they're so similar that the differences are so minor that even if I told you the difference between them, you won't remember it in a year. Okay, so let me just give some examples of these rather than defining them. So two examples would be like, hey, if A equals 6 and A plus 7 equals X, then X equals 6 plus 7.
Okay, so that's an example of substitution if we wanted to be technical. But if you wrote transitive, most times you would be correct as well. And with big ideas, right, you can try it and check your answer and see if you're right or wrong. So, I mean, you have unlimited checks, right? So it's not a big deal.
And then another example of this would be if you had A plus B equals 180 degrees, and you have C plus D equals 180 degrees, then A plus B equals C plus D.
And I'm just trying to give examples of common. Obviously, there's different examples. So these are just common examples of these. Okay. So that's transitive and substitution. We're going to be using transitive a lot. And that's why I put transitive first. We use transitive a lot more than substitution. Okay. So transitive, we're going to be using that a lot to combine things. It combines things.
So to combine two or more statements into one new one.
Okay, so it's to combine two or more statements into one new one. Okay. So again, I got to keep going, guys. I know this is a lot, but just remember, get down what you can, and if you need to come back and use, because I know some of you guys take absolutely stunning notes for Avid. So if you need to come back, this video, you can pause it, you can slow it down, speed it up, do whatever you want with it.
All right, reflexive. So this is going to be another big one. We didn't really use reflexive in first semester, but we talked about it.
It's going to be really big in the second trimester.
Okay. So what is reflexive? Reflexive is when something is equal to itself.
Okay, something is equal to itself.
Okay. So
there's going to be two examples of this. So reflexive can be used with sides and angles. And again, we're going to be wanting to prove triangles congruent. So we're really going to want to be able to say, hey, do these shapes share something?
Okay, so one way of sharing, right, because sharing is caring, right, is kind of this problem. You have two triangles and they share their butts, right? It's butt to butt. So I have A, B, C, and D. So I got one triangle on the right here, and I can label these triangles. So I got one triangle on the left, one triangle on the right. Now notice these two triangles, right? They share a side. Now you have this in any time you have a house or a structure, right?
rooms often share a wall. And if you guys have siblings, right, you hate that wall because you can hear your sibling, right? So if you have a shared wall, so the thing that we need to remember here, if they share a wall, it's the same wall for both triangles. So that would be segment BC is congruent to segment BC. And that's really important because if I'm trying to show that these two, like if I have kids and they have 2 bedrooms and they're complaining like, well, their bedroom's bigger. And I can be like, well, first, the wall that you share is the same, right? And then I can go forth and show that the rooms are the same size, right? And that one kid isn't getting an advantage. Okay, so that's a way that we're going to be reusing reflexive property a lot. So you really want to have this in your notes because that's super important. This shows up a lot. Okay. The other example of this is going to be if you have a big triangle. So let's say we have triangle ACE, right? You got your ACE. And then you put another triangle on top of it, but it's smaller. Okay. So what happens here is this smaller triangle fits right on top of the big one, and they share an angle. So this angle up here, angle C, is the same angle for the small triangle BCD, and it's the same angle for triangle ACE. So we can say angle C is congruent to angle C, and that's reflexive. Now, you're like, why do we care if an angle is congruent to itself? Because they're 2 different triangles, and we're trying to show the triangles are either congruent or similar. And that's what we're going to be working on in the next 2 months. Okay? So these are 2 examples of how we can do that. And I only have 4 minutes left, and so I am going to have to start rushing. Okay? So then we have all the parallel line stuff. So we have if parallel lines, then corresponding angles are congruent. So I'm going to go ahead and do a little example here. So I'm going to draw 2 lines that are parallel. I don't have a lot of time. I'm going to draw the transversal, and we know they're parallel because I'm going to put another little arrow there to make sure they're parallel. So corresponding would be like the upper right with the upper right, the upper left with the upper left, the lower left, I'm just going to do a shaded box, with the lower left, and then the lower right with the lower right. Okay, so it's a corresponding is a spatial property. Okay, and again, guys, I'm really sorry, but I do have to go quickly. So if parallel lines, then alternate interior angles. Okay, so sorry, I should go like this. That goes with that. Okay, so if I have alternate interior then, so again, I'm going to draw a set of parallel lines. How do I know they're parallel? I just add in an extra set of arrows pointing one direction. Okay, story of my life, right? For all my One Direction fans out there. Now remember, we're inside, so inside means inside the parallel lines. And they're going to alternate, but they're not going to be linear pairs, right? So they're going to alternate, but not be linear pairs. Holy moly. So I only have a minute and a half, and I have 4 more to go. So I'm going to flip this over. I'm sorry if you haven't had enough time. Okay. If we go over a little bit, that won't be too bad, right? Because we got 10-minute passing. Okay, so if parallel lines, then alternate exterior angles are congruent. So let's do a quick one like that. So I have parallel lines. Okay, the outside, right, is outside of the parallel. And then it's going to be just like alternate interior, but it's on the outside. Okay. And then I have if parallel lines, then consecutive interior angles are supplementary.
Okay, so what does that look like? I'm going to have parallel lines. I'm going to use letters for this. So if I have A, B, C, and D, that means that A plus angle C equals 180 degrees, and angle B plus angle D equals 180 degrees. Okay, because that's what supplementary means. Supplementary, right, has those two P's. It means they add up to 180. And I'm going to go over just a little bit. I just have two more left. I'm going to have people are leaving. That's a bad choice. All right, vertical angles. Okay, these are really important. So vertical angles, remember, happen when you see a cross, right? When you see an X. Okay, so if I had A, B, C, and D, that would mean that angle A is congruent to angle C, and angle B is congruent to angle D. So what this is opposite angles in, and I'm going to put in quotes, X are congruent. Okay, so opposite angles in an X, right, are congruent. So that's vertical angles. And then the last one, last but not least, is linear pair. So if you have a straight angle, right, a straight angle is 180 degrees, right? So that is 180 degrees. And if we have angle A and angle B, right, this is from angle addition, right? So angle A plus angle B equal 180 degrees. And hey guys, I really apologize for holding you over for 2 minutes. Just a couple things to remember. You do have a homework assignment on Big Ideas. It is due by the start of next class. And remember guys, if you pass this trimester with a C or higher, you're going to pass first trimester even if you failed.